what we want to do now is find the components of a vector. And what do you mean by components of a vector? Suppose that we have like an x-axis here and we have a y-axis here, and I've got a vector like that. And let's say that my vector is something here. Let's say my vector is 14 feet, and it's in an angle of, let's say, maybe 50 degrees right here. And so I want to know how the end of the vector, how far over is it and how far up is it? Okay, and because the origin's right here, and I want to find the coordinates of that spot right there, the x and y coordinates of it. So I would find how far over it is in x and how far up it is in y. And, well, that's pretty straightforward. How far over is it in x? That's going to be 14 feet times cosine of 50 degrees. Okay, so 14 feet. And that's going to be 9 feet. Okay. And the y is going to be 14 feet sine 50 degrees. And that's going to be 10.7. All right. Now, several ways we can do this. We can say, that we can now go back and say, well, my vector, we know that you can actually add vectors. A plus B equals some resultant vector. Okay, and so in this case, I can have a vector A and a vector B, and the two vectors add up to be that right there. Well, if that right there is going to be 14 feet and 50 degrees, that means that vector A has to be 9 feet, and vector B has to be 10.7 feet. Okay. Now, how do we say 9 feet in the x direction and 10.7 feet in the y direction? Well, what we do is we can define 3 unit vectors. A unit vector is a vector that has length 1. Unit means 1. So this is length 1. If it's in the x direction, we're going to call that vector I. If it's in the y direction, we're going to call that vector J. And if it's in the z direction, we're going to call that vector K. Well, since these vectors have no units, I know they're called unit vectors. Unit means 1, but they have no dimensions to them. They're only parallel to the x, y, and z axes. So we normally symbolize them, instead of a little vector symbol, with a little hat on the top of them. So our example right here, which was 14 feet at an angle of 50 degrees above the x-axis, that can be thought of as 2 other vectors like that. Okay, so this would be the x part and the y part. You can think of it as x part and y part if you call this vector A of that. And so we could write vector A, which is the sum of the two, as the x part in the I direction and the y part in the j direction. So we would write this vector A, it's 14 feet at 50 degrees. So So vector A is 14 feet at an angle of 50 degrees, and this 50 degrees is counterclockwise from the x-axis. Or we can write vector A and say that vector A is 9 feet I plus 10.7 feet J. Now, both of these are legitimate ways of writing vector A. This is magnitude and direction form at the top. So that's magnitude and direction. And on the bottom, this is component form. So we have found the components of the vector. Now, resolving components is one of the things you're going to be doing in lab. In lab, you're going to have a vector. You'll be given the vector, and you want to find the x part and the y part. Okay. Now, in the lab, all the vectors are measured from the counterclockwise in the positive direction. So if you had a vector in the fourth quadrant, that would mean it would have a positive x part and a negative y part. If it's in the third quadrant, it's going to be negative x part and negative y part. So both components are negative in the third quadrant. The y component is negative. The x component is positive in the fourth quadrant. In the second quadrant up here, the x component is negative, the y component is positive. First quadrant, both components are positive. Okay, so this gives you kind of the idea of vector components and how to resolve something in vector components. And that turns out to be very useful sometimes when we're adding vectors, as we'll see in our next example.